Hello, my name is Birasan Rajbhandari and this is my video demo for my Advanced Software Engineering Component 2 assessments. So this is my Leeds Beckett University email ID. This is my name, Birasan and Rajbhandari. My student ID is 77356804. My course is level 6 BSc. Tutor group is from Duncan Group 1. I understand that I must upload my full code to the upload link on my packet by the deadline. If I do not upload by the deadline, regardless of the GitHub commit, I will be subjected to a late penalty. I am recording a YouTube demo showing this form on the screen and showing and explaining my code with each question, and I will submit this form. I understand that if my YouTube demo video is over 15 minutes long, I will have to verify my YouTube account. I will put chapters marker in my video for each questions. I will read the assignment handing instruction before asking questions. I already read it. Answers to how you do the above are there. Example, I have used the latest Booz program found in here, and I have checked that I have the latest version of Booz, the TLL. Yes, the latest version is 1.10. I am using 1.1. Yes, it is the latest version. Next is version control. GitHub username is Birasan RB, as I have written here. What is the link to your repo? Must be the ASE GitHub Classroom. My link to the repo is this link. I have already posted. I have already posted it here. I mean, copy pasted it here. And paste link to your documentation on GitHub. When click, it should show your full documentation. I have already posted the link here, and here it is, the deployment website for the documentation. When I click on this, I have posted this link. It redirects to the documentation. Next is the total number of commits by part 2 by the part 2 deadline. My total commits is wait, this is Duncan's. My total commit is 50. As you can see here, it is 50. And these 5 more documented comments. Yes, so it's over 50. It's over 5, so it's okay. Updated readme.md with full details, name, etc. Yes, I have updated it with full name. Yes, my name, this, all of them have been marked as done and documented as what I have done. Yes, and use of interfaces and use of interfaces. Okay, so interfaces to be used for all classes where appropriate. So in your code and explain how you have used them. So the interfaces I have used are for the app canvas at first. So this is just a class that draws on a bitmap. So we can see this is, I have applied a singleton pattern on this class. So we don't need too many canvases. We can just use one canvas to draw on multiple bitmaps. So I've applied a singleton pattern, design pattern on this. This is the position of the cursor. This is the pen color. This is the pen size. This is the pen. This is the canvas size in XY axis. This is the constant Y default size of the canvas. This is the bitmap reference. This is the graphic context reference. This is the constructor which sets the initializes the object. Okay. This is the this is the method that returns the singleton instance of the object of the canvas. This is the X pose Y box property, Y pose property, and this is the pen color property. So getter setter, and this is the circle method that just draws a circle on the bitmap. This is the clear function that clears the bitmap. This is the draw to function that draws from the current position to the target position. This returns the current bitmap, and this is the move to function that moves the cursor to the specified point. This is the rectangle that draws the rectangle. Resets the pen color, pen, and the expose white pose of the canvas. This sets all the parameters of the canvas. Sets all the parameter of the canvas and resets. I guess you could say this resets the canvas and specifies the size of the canvas. This sets the set color. This sets the color of the pen and creates a new pen. Returns a new pen to be used by the canvas, and this just draws the triangle on the bitmap. This just writes text on the bitmap that the canvas is currently using. The second class I have used an interface on is the parser class. I had to replace this parser class since there was a 20 command restriction, parse restriction on this parser class, so I had to replace this class from scratch. So we can see here, this is the command, it's a command factory and stored program reference variable. This is the constructor that takes the factory and the program, stored program. And this is the parse command, which parses a single line single line of command. It parses the single line boost command. If the this line shows that if it is a comment, it will just skip the line, and this just cleans the line. We can see here the function is here, it just cleans and trims the line and manages spacings. This is an array that splits the given a line of command in using the spacing, so that we can separate the command and the parameters. So this takes the command, separates the command here, and this part combines the string in the whole parameter into a single string. This statement just checks if the given command is a valid command or not. If it is not a valid command, it goes inside the if block, and it checks if the given command is a existing variable or not. If the variable does not exist, it will throw an exception. If the variable does exist, then it will combine the command and the parameters again, since the variable commands take the whole command name and the parameter as actual parameters, and this create existing variable from the specified name. Yeah, this stored program gets the variable. This stored program, it gets the existing variable from the stored program variable array list, and checks the type of the variable list and creates a command of that type of variable, so that variable of so that a command of that type of variable will be created. Since the variable command has a behavior where if it already exists, it will override the existing variable command. If it doesn't exist, it creates a new one. So it creates the type of variable object, creates the type of variable objects, and returns it. So to create the type of variable object, it returns the type of the command object, and after we get the text, the type of the command object, it passes into the command factory, which creates the specific type of command, and it sets specific type of command, and it sets the reference type of the reference of the stored program, and the parameter it passes to the command and compiles the program and returns the compile command. As for and second function is the parse program, which parses the whole given program as a string. So it adds a write command at the end, which does not really does anything. It's just there so that there won't be any problem when we do program counter jumps. and this is the exception message. So all the exception that are accumulated by the loops per command are accumulated here, and this is the array which splits the which is this is an array that holds all the command which is split by the backslash n. So it splits all the entered command by lines and rows, and this is a variable stored program variable that checks if the syntax is okay or not. And so this whole for loops until there is um, no command left in our given array. So yes, this line just fixes the command, and if the array is equals to nothing, then it continues the loop. It skips since it is a blank line. And so here the each line is passed to the parse command function as above, which parses the command, compiles the command, which parses the command, compiles the command, and return the compiled object. If the compiled object is if the command compiled object is a method, then it creates a local variable for the method with the same name and type of the method, and it removes the command from the command array list, since local variable does not need to be executed when we run the program, uh, since local variables values are allocated by the call command when we call the commands when we call the method command. uh, so this also creates the local variable for the former parameters of the method, which so it creates the local variable, assigns local variable into the variable array list, and removes the command from the command array list so that it won't be executed when we run the stored program. And this is just an exception. If there are exception, then it will compile the exception and turn the stored program syntax into false. So it just accumulates the exception as we go and compile the programs, and in the end, if there are any exception, it will throw the exception and the accumulated text as a string. And that's about it for the app parser, which implements interface, which I have implemented from scratch. So mainly I only implemented this because this had a parser limit of about 20. So yeah. So the next one is for the unit testing. Unit test for all of my class. So in your code, yes, I have unit test for all of my class. So you can see here for the app canvas, most for drawing features, I have unit test in a single class. Another parser stored program, yes, multiple tests in a single class for the canvas. This is for the array, which this is for the array which this test if the restriction has been removed or not. uh, so object creation restriction is removed or not. The limit was 3, so inherits it and creates tests if the object restriction is removed or not. Same for the call, it also tests for the boolean restriction and the compound command object creation restriction, as well as the test for the else command. Also the restriction is removed, since boolean has restriction on all. It if one of them trigger the restriction, all of them break, so I had to put restriction test for all of them. So test the object creation restriction also for n, also for the for statement, and also for the factory command factory has multiple tests, such as test circle command if execution is raised or invalid value are inserted, and test unit test for multiple program variables stored pen position are correct, and unit test for draw to command variable storing pen position are correct, and creation design pattern singleton pattern test to check if the same object is created, if the same object is created, and unit test for move to command. So all of them are using the singleton design pattern for the app canvas. another is for, which is also testing for restriction, object creation restriction. Also for the if statement, it is also testing for restriction. And the in statement, also checks for object creation restriction removal. And the method, which tests for boolean and compound command restriction. For the real, also checks for compound the object creation restriction. And test app while command while will also text for boolean restriction. And app test app parser, which tests the parser for the max parse limit. As we can see here, if an exception is thrown, yes, an exception uh, is thrown, exception not thrown is turned to false, and is true is done to false. So the same logic is used in all of my tests, on my tests. We can also see here there are 60 command restriction. What is this for? App test program, test app stored program. This is for the stored program, which I had replaced some function of, which also test for max command execution. We test the max command execution, which was about I don't know, 50 commands was the limit. Yeah, 50 commands was the limit. So as you can see, all of my tests are using the same logic. It declares a variable called exception not thrown is equals to true. If an exception is true, it changes to false, and when it is false, the true fails and the test fails. The test, mostly test, all of the tests are written for all of the classes. Uh, unit test for all of my classes. So in your code, unit test documented with XML comment clearly show its purpose. Yes, I have documented all of them using XML documentation, as you can see, and also generated the documentation here. Oh my bad. So for example, test array class, command factory class, all of them are properly documented and properly documented. Where am I? Unit test for all our class, unit document, unit test run pass. Show them running in the testing framework, giving green ticks. Yes, I'll do that. Too many tabs open. Let me just close them. Test, run all tests. You can see that all of them passed. If one breaks, most of them break, since all of them has the same static restrictions, so all of them pass. We can see that all of them passed. All of them has passed. Let's see, next one is design pattern. Past design pattern should be written using design pattern where appropriate. Okay, factory design pattern used for command generation. So it in your code and explain how it works. What? So factory design pattern used for command generation. So it in your code and explain how it works. Yeah, I did extend the factory command factory app command factory to add new commands to add new commands to the factory. As you can see here, a factory that extends command factory, which creates command object and overrides make command method to create additional commands. So on the given string, it makes the new commands and returns the command. It uses the factory design pattern. When asked, it will create the object and return the object, as we can see here. Mostly, yeah, it's mostly being used by the app parser. Where is app parser? App parser. It's mostly using by the app parser. As you can see here, the app parser is using it to make command of this with the specified string, as I have explained for this function. Mhm. So generally, it just acts the object acts a command factory for a specific object of that implements a specific interface, and it returns the specified object to the caller or the client. So it does help us reduce dependency into a single point, and helps us reduce breakpoints in our code, and reduce dependency and lose coupling, I guess. Uh, okay, additional design patterns. So any other design pattern, explain what they are. As I have explained, I am using singleton pattern for the app canvas command. Uh, Here is it. It restricts it restricts the creation of an object to a single instance. So if the object is created, if the object is not created, which is it is specified as static. If the object is not created, it would create a new object. If it is already created, it just returns the static value. And the constructor is private, is specified private static, since nobody wait is hmm? this is the sorry, this is not the constructor. The constructor is private static, so no one can create an object of this class, and we make the get app canvas singleton instance a public class, so that if it already exists, it returns the instantiated object. If not, it creates a new object and returns new object. So a single object will only be present at a time. Additional design patterns. So any other design pattern, explain what they are. Yeah, singleton pattern. And I have also implemented NBC, model view control, which separates the design a design pattern that separates the design logic of our app, and that I will be showing in the end at the end for the extras, where I have developed a web version of the Boost using the ASP.NET MVC template. Another implementation detail. Before moving on, so that you got the latest Bootia library installed, so the output from Boost about method which puts this person, if you have to read it, then just so just run the program. Let me close this. So as you can see, I have the latest Boost installed. Let's see, variables, variables. Um, replaced in class, showing replaced in class showing it running. Replaced in class showing it running. Yeah, I did replaced in class. Boost example program. Let me open it. Where are they? See, Boost example program variables. Let me see. Boost example program, two variable, one unrestricted in dot boost unrestricted boost, and put an image of it running the same directory as the boost program. So the program running and so your code. So the program running and so your code. Yeah, I have already replaced the images, but I will run them anyways here. So this is my boost command for the first one. Copy, paste, run the first one. This is the for the first one, which image I have already inserted here. The second one, copy, insert, run. This is for the second one. and this is for the second. This is for the second one. Copy, paste, run. This is the unrestricted reals. This is for the two unrestricted reals. Reset, run. So this is for the unrestricted reals, which I have already inserted the images. And this is for the arrays. And this is for the arrays. This is for the arrays. And so this is for the arrays. As you can see, I have already replaced it. And third is the restricted arrays. As you can see, I have already put the images here. It runs, and this is for the third restricted array. It's the same thing. So also I accidentally closed it. So I have already put the images here. I put the images here. So uh, so all of them run. So I will be explaining the code now. Running the same direct as a boost, and show the program running and show your code. For the int class, it's pretty simple. Where is the int? Int. So I just removed the restriction for the int class. Comment that extends the boost in comment to prevent object creation restriction extension from occurring, and it just overrides the restriction function. So even if it calls, nothing gets restriction. It is the same for real as well, just overrides the restriction, so that it overrides the restriction function. Even if it is called, it will not invoke the restriction. The static value will not be invoked. As well as for the arrays, I have done the same for the arrays as well. It does not let the restriction exception to occur, so it reduces the restriction. A command that extends the arrays to prevent creation restriction exception from occurring. The same for the array as well. So I have shown you the code for all three of them. Paste the link of the image file in your repo. Paste the link of the image file in your repo. Leave all link field blank. Let me fill up the links. Okay, so let's fill up the links. Easy assignment, example programs, variables. For which one? This is for int. So which one? Two variable, one unrestricted boost on which one? One unrestricted in boost, one unrestricted in boost. Years of run in the same directory. So for two variables unrestricted in page, this is the link, and paste the link email. So this is for two variables unrestricted real. Okay, two unrestricted real.png. So unrestricted, one unrestricted, two, this is two unrestricted, one unrestricted. Oh, I don't see the one unrestricted. One unrestricted. Let's see the other real unrestricted. I guess this one. Unrestricted real. One doesn't exist. On the one unrestricted real isn't there, so I'll put the two one. Uh, the then one unrestricted array. One unrestricted array, restricted unrestricted array dot png. So this one unrestricted array unrestricted array png. Unrestricted array png. Okay, and if for a while. Okay, let's go with if for a while. While working on unrestricted, so it running while it's working unrestricted, so it running boost example program if and loops unrestricted while loops and put the image of it running in the same directory as the boost, so the program running and so your code. So I will do the same for ifs and loops. So let me run this. I closed it. So go here and so open unrestricted unrestricted. So I will show all of it running to be. So you can see here run. So this is the unrestricted one first. This is the first one, as you can see is the same as here. This is the second one. Wait, let me do this thing. So if we change the value to 5, it will show this. As we can see, this is the unrestricted ifs. Let's run it. We can see here the unrestricted image. I have already put it, and unrestricted image 2. If we change the value to less than 50, so let's take it 5 and run. So we can see it sets the value unrestricted for unrestricted while. Let's show the while adding. So as we can see, it is running as shown in the example. I have already put in all of them. So let's see. Run. My bad. So this is the output. As we can see, I have already put it in the example image. This is for the for loops run. My bad. So this is the example. As we can see, I have already inserted it, and this is for the final for loops. So we can just copy this, copy paste it, refresh, and as we can see it runs. As we can see it runs. Let's close this, and so I put image of it in the same diagram, so the program running and show your code. So for ifs, for the ifs, as we can see, a command that extends boost if command to prevent object creation restriction exception from occurring. So if restriction to avoid the restriction obstruction, I override the restriction. So the restriction, even though it is invoked, it will not throw an exception for the restriction, and also calling the restriction method, so that the restriction static method will be decremented. And also for if and else, also can see here we remove the restriction in the same way. Remove restriction by overriding and remove restriction the restriction function, which is from the app else and else. And ifs for while loops, I have also done the same. We call the reduce restriction and override the restriction command, and then and for command, it is also the same. We have overrided the restriction command for the for loop as well, and for the end. As we can see, it is also overriding the restriction function, and I have overridden the execute function. I have overridden the execute function. This I'll get to when I'm explaining the method. This is also remove the restriction. If else while loop, as we can see, we have also is the same. Just remove the restriction for while if for all of them. So please paste the link to the image file in your repo. Leave also answer no. So unrestricted while, okay, unrestricted while ifs and loops, unrestricted restricted unrestricted while, unrestricted while, unrestricted unrestricted whiles. Instead of one, unrestricted ifs only, unrestricted whiles. This is for the for loop. Put an image of running ifs and for is called unrestricted for. Most probably unrestricted for. Unrestricted for is probably this one. The link unrestricted force, and the third one is unrestricted ifs. Unrestricted ifs. Unrestricted ifs. Restricted ifs. Else working unrestricted. Yes, else working unrestricted, else will work without restriction. So you'll have to explain how you did it. Yeah, else I already explained. It does the same thing, just removes the exception, overrides the restriction method. Paste the link paste the link to the image file in the repo or what you did. Explain, leave a link. Let's see. This is if statement. So as it so else is working. Working as well. So replace method class, so it running boost example program slash 4 methods and put an image of it running in the same directory as the boost program. So the program running is so the program is class. So for the if methods, it's running again, and let's go to methods. Let's start with restricted. This is empty. So let's start with this one. As we can see, it is working as I have already put this here. For the second one, my man, it's the same thing. It's the same thing. It's literally the same thing. As you can see here, they are both the same thing. And method extra, this is something I came up with as an extra to show that the method are working. So the method are working. Let's close this. Let's see. And so that I'm run. So good. as for the method class, I had to rewrite most of it. So as we can see, this is the app method that I had to implement from scratch, that replaces the method command to prevent limited object creation and restriction exception from occurring. Since last time we could only create one method or something, method had a hard-coded creation limit, restriction limit, extends boost compound command, corresponding command attribute of compound command class is needed. So yeah, so the corresponding command attribute is needed uh, to map the end line and the method together, and the call command together, which is in the compound command. That's why we extended the compound command. So this is the method name, method return type, local variables properties, method properties, type properties. This is the constructor, just reducing the restriction static value by a lot, so just in case no error occurs. So just overriding the restriction so the restriction error does not occur. Checking in this just overrides check parameter, so we don't need to check parameter in the previous ways the base classes has done, so we just overrided this. So the compile method just calls the base.compile. It passes the parameter list into expression, assigns the line number, as you can see here, assigns the line number of the method, and pushes into the new stack that I had created when I created a new App Store program and created a new uh, stack and data array. It's a method array list. Since the previous method array list uh, was private, and was not private, sorry, it was limited to method type only, so I could not insert the new type of method, so I had to make a new array list in the stored program. And where was I? Yeah, so I was here. So it holds all the parameters of the given method command. If array length is less than 3, it just checks for what happened. Uh, Sorry, where was I? It just checks for invalid number of parameters. So this assigns this assigns the this splits the parameter with using the spaces, and assigns the return type of the method and the method name. And if the parameter list is not accurate, it will just throw an exception. And this is the variable that holds the former parameter types and name as a single string. So it loops through the array. So it skips the return type and the method name, and puts all the parameter in a single string. So, and then splits the former parameter by the comma. Since the entered format is something like this, I have written comments here it splits by the comma, and assigns the assigns the method local variable former parameter. This just loops through all the local variables and checks if uh, local variable the splitted local variable type and name parameter are accurately inserted by the user or not. And it recombines it and insert into the local variable um, attribute of the object. So the execution method, it just updates the stored program's program counter to the end line, the corresponding end command of this method, which is popped from the stack. So it updates the end line number and jumps to the end line, and continues execution after the end line. So it does not get executed when it is created. So methods are not supposed to be executed at this call. And this just adds to the new data array list method array list that I had created. Since the old one I couldn't enter, I had to create a new one. So as you can see, typecasted stored program reference into child class reference to our static binding error, widening casting, and add itself on the new app method array list. So method, I need to explain also the end if I want to explain the method. And I also had to remove the restriction, and this, as I have explained, so I what number, so so for the new method I have to update the corresponding sorry, my bad. I have to update the corresponding methods which is bought from the new stack that I had created in the stored program. It bought from it the corresponding program, the method call, which is assigned a end. It has, they have to uh, assign each other's line number to each other to jump around with the program counter. So this is for the end. As and also the app store program, I had overridden the app store program. As you can see, I have implemented a new data structures for the stack. Since I couldn't do safety check for the stack, I had to create a new stack, and I had to implement new method pop and push method for the stack. And I also had to implement a new method list, because the new list since the original method array list only accepted method type object and didn't accept app command method, which I created to remove restrictions. So I had to make a new one, and I had to add methods to add and remove from them. As you can see, I had also the run program was updated. I had to implement the run program, since there was a execution limit on the stored program. As we can see here, it checks if there's any command left and gets next commands program counter, which we can manipulate to jump around in our program. Gets the next program counter. According to the next program counter index, it returns the command and execute the program. If any error occurs, it takes an syntax okay false and throws an error if an error occurs. And that's about it. So many tabs. Okay, so the next one, paste the link to the file in your repo. Leave all link blank if you, no, let me put a link for the methods. Method unrestricted.png. You can see it is running. My bad. Yes, have you done anything that is additional and substantial that is not was something challenging, some web version or different type of object, such as text based graphics or additional other tools command that do something programming, other graphics, civics, system parts, system program. Well, yes, I have done something extra. I have created a Booz web version using ASP.NET framework that uses the FBC design pattern template. So let me show it here. Let me close this. So let me go over here, controller. So when I run it, go here, over. Okay, uh, so this is the web boost version that I have created for the extra. This uses the ASP .NET framework, the model view control framework. So generally, I have something like, right, hello there, hello there. See, the executed boost command is written here. I have some extra that I have written. For example, example.boost, add your program here, a bunch of command that I want to execute. So I can just put it here and it just runs the command. So this is the extra that I have done and the web boost version. So let me minimize this. So what it does is so I use the template as the ASP template. Let me open everything up so I can see. So this is our view, the HTML, and it uses a naming pattern. So the controller calls all of the views when by if we call a by controller name, it returns a view. So so how it works is we have a Boost web version HTML, which is the view that is loaded when you want to execute the Boost program. So here is the text field. Where is our text field? These are the styles. Here's the text field. It is a form. It takes the input from the user. On the button click, this is a submit button as run. On submit, on submit, uh, on submit, as we have linked model, which is a object that holds the data of our application. On submit, it will update the data in our model ASP for code text. As we can see here in our code text model, it updates the data, which is our input command. On submit, it populates the data, creates a new object, populates the data, and then it calls the controller home, ASP controller home, which is this, which controls the home views, and calls the controller where is the controller, home controllers web boost version action button click, in which the model's object is passed into on submit, and it creates the new canvas instance and factory. It parses the program, it takes the program, parses the program, runs the program, then it turns it into a bit image. It takes the bit image and turns it into a PNG file and saves it into the file from saves it into a PNG file. Then it redirects to another controller, which the Boost web version controller, which loads the Boost web version view and returns the view. On reload, it will reload the saved image to the image file, and that's about it. Just shows what the output has, what the output we have from our command, and just execute, just saves the image and just reloads it to the web page. And yeah, that's about it. It's pretty simple. So I have put a screenshot of my Boost over here. uh, AI used I didn't really use much to me. Did I use AI? No, I did not really use AI. I did use AI to research about base 64, but I didn't really needed it, so I guess I don't need to write it. I didn't really use the base 65, I just discarded it, so it doesn't really count, I guess. Other non-standard faculties used nothing really. Any other comments? No, not really. So, any other comments? No, not really. Now I understand I must upload my code to the my build. I understand if I don't submit my code before the deadline without agreed mitigation, then I will receive the late penalty. I must submit this form. Users message here. Respond recorded. Please read the hand instruction manual and see the flexible. See it is all lesson. Yes. So that's it. Thank you. I'll do a recheck of the form and submit it. Thank you.